My dear students, class 10, let's recap. In our last class, we discussed the nature, structures, and the features of spherical mirrors. Today, we have taken a topic that is ray diagrams of spherical mirrors. You know, there are two types of spherical mirrors. One is concave, another is convex. You know, both the mirrors follow the laws of reflection. Then, what is the necessity of ray diagrams? Because two intersecting reflected rays are required to locate the image formed image formed by the spherical mirrors. So to locate the image or to know the image location, we have to know two intersecting reflectedness. So at least two intersecting reflected rays are required to know the image location. So let's discuss how the rays travel after reflected by the concave and convex mirrors. So there are four cases in both the cases. So let's discuss the situation, the case number one. So look at here, it is a concave mirror and P the pole and PC the principal axis. Okay. Now the ray parallel to the principal axis, that is called incident ray, after reflection passes through a point that is called principal focus, denoted by the symbol capital F. So incident ray and this is reflected ray. The reflected ray passes through a point on the principal axis that is called focus. Now CE is the normal to the point of incidence, and as per the laws of reflection, the angle formed between the incident ray and the normal is called angle of incidence, denoted by the symbol small I, angle I. And the angle formed by the reflected ray and the normal is called angle of reflection. So angle of incidence is equal to the angle of reflection, that is we have discussed under the laws of reflection. This is the first case of concave mirror. Then what happens in case of a convex mirror? Let's look at the diagram here. Now you look at the ray parallel to the principal axis. After reflection, returns back to the same medium. Okay. But you see, the reflected ray appears to have come from a point behind the mirror, that is called the principal focus. And here the principal focus is virtual, not real. And here also CE, if extended, it is called normal, and the angle formed by the incident ray and the normal is called angle of incidence, and the angle formed between the reflected ray and the normal is called angle of reflection. So angle of incidence is equal to the angle of reflection. But here the reflected ray appears to have come from a point behind the mirror. This point is called principal focus, of convex mirror. But here the focus is virtual. Come to the second case. Now look at here. A ray, in case of concave mirror, a ray passing through the principal focus after reflection emerges parallel to the principal axis. Just reverse or vice versa of the situation. A ray passing through the principal focus after reflection emerges parallel to or travels parallel to the principal axis. And here the C is the normal to the point of incidence. So angle of incidence is equal to the angle of reflection as per the laws of reflection. So come to the second case, in case of convex mirror. What happens here? Now you see the incident ray directed towards to the focus. Directed toward the focus. After reflection emerges parallel to the principal axis or travels parallel to the principal axis. Now the incident ray is directed towards the focus, the virtual focus, but it is reflected from the point of incidence. Okay. So the angle formed between the incident ray and the normal is called angle of incidence, and angle formed between the reflected ray and the normal is called angle of reflection. So angle I is equal to angle R as per laws of reflection. Come to the situation, the case number 3. This is very important. Please remember, a ray passing through the center of curvature, you see center of curvature, after reflection returns back along the same path without a deviation. So angle I and angle R coincide each other. So here that is means angle is 0, no angle is formed. So you see, so the incident ray after reflection passes through the same path, along the same path, when the incident ray passes to the point that is called center of curvature. There is no deviation or no change of path. This is the important case, please remember. Now come to the third point here. In case of convex mirror, what happens? A ray directed towards the center of curvature, because the center of curvature, the behind the mirror or behind the reflecting surface, and that is virtual, and the reflected ray returns back along the same path from the reflecting surface. And the incident ray directed toward the center of curvature after reflection returns back along the same path. Okay, so this is very important. Now come to the situation or case number 4. Now you see the incident ray falls at point P, the pole, obliquely, making an angle. So this is called oblique incident ray falls at the point P. So P is the pole. So after reflection, it returns back the same medium. Now the angle formed between the incident ray and the principal axis, that is normal, is called angle of incidence. And the angle formed by the reflected ray and the principal axis normal is called angle of reflection. So angle I is equal to angle R as per law of reflection. Same thing happens here in case of convex mirror. So look at here. Here is the reflecting surface because upward. Here the inward surface is reflecting surface. Here is outward surface is reflecting surface. So the incident ray when falls at point P obliquely and it is reflected in the same medium. Okay. So as per law of reflection, incident ray, the reflected ray, and the normal, they all lie in the same plane. Now you see, so the incident ray, the P is the point of incidence and P the pole. After reflection, it is reflected the same area. Now two angles are found. This is called angle of incidence between the angle that is incident incident ray and the normal, the reflected ray and the normal. Angle of incidence and angle of reflection. So the angle I is equal to angle I. So these are the four cases or four situations how the rays after reflection travel in case of concave mirror and in case of convex mirror. And these ray diagrams will be useful to locate the image formed by the spherical mirrors. So we shall discuss how the images are formed by the spherical mirrors with the help of ray diagrams in our next class. Stay tuned to watch our videos. If you like, please subscribe and share. Thank you for watching.